So our third lesson in this chapter deals with hyperbolas. And again, we start with our basic definition. It's a set of all points in a plane whose distances from two fixed points have a constant difference. So an ellipse dealt with a constant sum. Now we're going to deal with a constant difference, which means we are subtracting those distances. Again, we'll get into the definition a little bit more in class. So let's start by looking at the picture. So obviously the entire shape is different, but another big difference is the fact that the vertices and the foci have swapped. They still have the same letters, so the focus is still with C, the vertices are still with A, but now C will be the big part and A will be the small part. And so again, if we were to take this shape and kind of put it on a coordinate plane, you would kind of visualize the following letters or coordinates. Okay, our center is at 0, 0. The vertex is going to be at A, 0. The focus is at C, 0. And when that happens, especially for the ones that open, I'm going to say open left and right, you're going to have this sort of a formula where it's x squared over a squared minus y squared over b squared equals 1. So again, subtraction is kind of a major change here. But it's also going to be a lot easier to figure out what a is because it will always come first. With an ellipse, we had to look for which number down here was bigger, but now A will always come first. And so we also have a relationship between A, B, and C, and now C will always be the big number, and it's going to equal, C squared will equal the sum of A squared and B squared. So again, some Pythagorean theorem stuff will come into play when we discuss why that is true as well. But again, there's a nice proof in your book. You can look at that. I'm sure we'll look at that in class at some point. One thing this picture does not show is what's going on with that B value. So if I were just to kind of draw in kind of a slant asymptote that goes through like that. Basically, if you can imagine the height that we're at right above the vertex, so right around there. So I'm just going to bring that height a little bit over to here. That distance from the center to that dot I just drew in there, that's B. So the coordinates for this would be 0, B, and that might also be something good just to jot down, but it helps us kind of figure out, that point, right, well, that's a big dot there, but right around there where it would touch right above the vertex. And so we have this part of our formula where a slant asymptote could be discussed. Okay, so a lot of important info again here. You do not need to memorize all of this. Just to highlight a couple things though, this is the one that we were just looking at where it opens left and right. If we were to open up and down, you would just see the y squared part come first and it would have a squared underneath it. But again, a lot of this stuff here will come from the picture. We have this Pythagorean relationship that we should know. And then this stuff right here kind of relates to what I was just talking about in the previous slide. And we might look at that in class, but don't worry about that for the video right now. So let's look at two examples, and then you can try two on your own. So the first example gives you the equation. We need to find some different parts of the picture. And just like the ellipse video, you're going to notice that it's not set up the right way. We need to, again, get this side to equal 1. So I want to divide every single part by 36. So if I went through and I did that, I would have x squared over 4 minus y squared over 9 equals 1. And what I can tell from this is the following. A squared has to equal 4. The first part will always be a squared now, so that means a equals 2. Okay, I know that b squared equals 9. So b will equal 3. And then c squared, so remember that c squared equals a squared plus b squared, which would be 4 plus 9. So c squared must equal 13. That means c equals the square root of 13, which is, it's about 3.606. So again, if I were to maybe make a picture of this, I suppose one thing I should have written down a little bit ago, the fact that x squared came first, that tells me it's going to open left and right. Okay, so if I were to draw a picture of this, okay, I'd have to go 2 A is 2, so I have to go 2 to the right and 2 to the left to come up with my vertices. The foci will be on the outsides of that, so another, 1.606 away, so maybe something like this. Come on, there we go. Again, it would just kind of open up like that, just so we kind of get a visual sense of what it's going to look like. Okay, but in this case, if all they're worried about is the vertices and the foci, I could easily write them out this way. The vertices will be plus or minus 2, comma 0, and the foci would be plus or minus 3.606, comma 0. And we are done with that example. Next example, now they give me parts of the shape, and I need to come up with the equation. So they tell me where the foci are, so they're telling me the C value, and they also tell me that the conjugate axis has a length of 2. So from this, like I said, I know what C is. C would have to be 4. And when they talk about the conjugate axis, that's kind of like the minor axis in the ellipse. They're telling me the B value. B is going to be half of that length, so B would be, there we go, B would equal 1. So I need to figure out what A is going to be. So I know that C squared equals A squared plus B squared, so I plug in some things. C squared would be 16 equals A squared plus B squared is 1. So I know A squared would have to equal 15, which means A is the square root of 15, or about, it's about 3.873. And then also if I think about where the foci are, so 0, 4 and 0, -4, the y values are changing. This tells me it's going to open, that is really an E there, it's going to open up and down. Okay, so I just like to draw a quick sketch of this, but I know the foci are going to be up 4 from the center and down 4, and because I know what A is about 3.873, so they're actually going to be very close to the foci. Here are my vertices, and it's just going to open up something like that, so not very exact. But if it's going to open up and down, that means y squared comes first, so I'd have y squared over A squared, which was 15, minus x squared over b squared, which is 1, and it has to equal 1, so there is my equation. Okay, you have 2 questions on the back of your notes now. That'll be examples 5 and 6. I want you to try both of those, and the next couple slides here will have a written out solution for you.